Welcome back. This lecture is going to cover systems and feedbacks. We are going to define systems in a general sense, why the Earth can be considered a system, and talk about some feedbacks in the Earth system. We will cover more feedbacks throughout the course, but today will be a primer for some. So let's get started. First, let's define a system. A system is any collection of environmental elements or components that interact with each other and that we study as a collection. Systems can also interact with the outside world. So what are Earth systems? Well, the atmosphere, hydrosphere, lithosphere, and biosphere are all systems. It should also be noted that systems can be much smaller than the entire lithosphere, or biosphere as well. A pond or a tree are also systems. But the functioning of a single puddle or a single tree won't affect the entire Earth too much, so we aren't going to talk about them individually in this class much. The Earth as a whole is also a system. Each of the four subsystems, the lithosphere, the hydrosphere, the atmosphere, and the biosphere, all interact in this system. So is Earth a closed or open system? Well, it is closed with respect to substances or materials. Remember, materials or chemicals are recycled on Earth. This is the concept of spaceship Earth. But it is open with respect to energy. Energy is continuously received from the sun. So how do we describe a system? We have to define system state variables, system processes, system inputs, and system outputs. System state variables are properties describing the system, like temperature. System processes are any processes that happen in the system. If you're talking about a tree, then you will want to describe and measure photosynthesis, respiration, growth, and so on. System inputs are all the things that go into the system. For the Earth, the input would be solar energy. For a plant, inputs would be sunlight, water, and carbon dioxide, shown on the right there. For a car, the input would be gasoline. For humans, the inputs would be food and oxygen. Finally, system outputs are all the things that leave the system. For the Earth, the outputs would be infrared waves. For a plant, the outputs would be oxygen and organic matter, shown on the right there. For a car, the outputs would be water vapor, carbon dioxide, and noise pollution. For humans, the outputs would be water vapor and carbon dioxide. Now that we have an idea of what a system is, let's define a feedback. A feedback occurs when the output of a system also serves as its input. That is, what the diagram to the right is showing. Feedbacks can either amplify an initial change, that's a positive feedback, or they can counteract it and stabilize the system, that's a negative feedback. Earth and its climate have a lot of complex feedbacks, and we will learn about some in this course. Here are some good definitions of the two types of feedbacks and an example of each. Remember, feedbacks operate to either amplify or counteract an externally caused initial change. Positive feedbacks cause a state variable to change in the same direction as the initial change. This is destabilizing, amplifying, or is said to result in a runaway effect. An audio system and microphone feedback with respect to sound is an example of a positive feedback. Negative feedbacks cause a state variable to change in the opposite direction of its initial change, that is, stabilizing for a system. A thermostat and heating and cooling system with respect to temperature is an example of a negative feedback. This slide also covers examples of feedbacks, just biotic examples are given, meaning that an example involves living organisms. Another example of a positive feedback, one that involves living organisms, would be pathogens and the number of infected people. The more people who have a virus, the more uninfected people will be exposed. Then more people will get sick, and so on and so forth. It's a positive feedback loop, and over time the number of infected people grows exponentially. That's shown on the right there in the upper portion. Another example of a negative feedback, one that involves living organisms, would be a predator-prey relationship. In the example on the right, we have a wolf and elk. The more wolves there are, the more elk they will eat. This decreases the prey population, and then wolves are not able to feed as much. As a consequence, wolves die and have fewer babies. Freed up from predation, the elk population increases. Having more prey, the wolves are then able to increase in number. The change in one variable causes the opposite change in the other variable, and the system bounces back and forth, but is stable in the long run. A concept we also have to cover that relates to systems is the concept of equilibrium. An equilibrium is a state of physical balance. In other words, the system isn't changing. That is visualized in the image by the ball. If it is not rolling, it is in a state of equilibrium. But there are stable and unstable forms of equilibrium. For an unstable equilibrium, the system is in a state of equilibrium, meaning it isn't changing, but the slightest nudge and the system will change. So when the ball is at the top of the hill, it is in an unstable equilibrium state because it will tumble down if there is the slightest breeze or vibration. But for a stable equilibrium, there can be slight nudges and the system returns to the same equilibrium state. That is shown by the ball at the bottom of the divot. The ball may roll around a bit, but it will eventually calm down and stop rolling in the exact same spot it was in before. It would take a really big nudge to push it all the way out of the divot it was in and into another. This relates to an important concept, resilience, which is the capacity of a system to recover or bounce back to the same state. Systems will have very different capacities to bounce back following perturbations or changes. In the diagram, the height of the walls may be factors that affect resilience. The state that the system was in to begin with will also be a big factor, meaning whether the equilibrium was stable or unstable. Resistance is also an important concept. This is the ability to not be affected by a change. In the scenario shown, how heavy the ball is would affect resistance. Of course, most systems don't consist of a ball and an uneven surface. We are curious about how the Earth system will be affected by things like deforestation or increased greenhouse gases, but understanding these terms will help us to discuss them later when those other topics come up. We are going to talk about some real and important feedbacks in the Earth system, and to do that we need to make sure everyone has a good understanding of albedo, which is the degree of reflectivity of a substance. It is actually the ratio of reflected to incoming electromagnetic radiation. Lighter objects tend to have a high albedo, meaning they reflect a lot of incoming solar radiation, and that radiation doesn't warm the Earth system. Ice and snow each have a really high albedo, while water and dark vegetation each have really low albedos. I have provided a table with the approximate albedos of many different surfaces. I'm sure you all have experience with albedo as well. For example, it is much easier to walk barefoot on light pavement during the summer than black asphalt, and this is due to the differing albedos of the surfaces. There's a famous thought experiment in which life could potentially affect the planet via differences in albedo. It is called Daisy World. Daisy World is a model of a hypothetical planet and an example of homeostasis. You start by imagining a very simple planet that has only two species of life on its surface, white daisies and black daisies. The growth of black daisies reduces the planet's albedo, so temperatures warm, and plants grow better when it is warmer, so this acts as a positive feedback. But at a certain point, the temperature will exceed the black daisies' thermal tolerance. They are black, and so they retain more solar insolation. This provides a check on the runaway positive feedback. This is when the white daisies will have a competitive advantage. They will grow and increase the planet's albedo, so the temperature cools. But plants tend to grow less when it is cooler, so this acts as a negative feedback. You can see how the system has built-in feedbacks to remain within certain temperature extremes. Now for the real world. There is a very strong ice albedo feedback that is a positive feedback on Earth. This is a loop involving snow or ice cover, or lack thereof, and albedo, and it can cause runaway warming or cooling, even with a small initial change. Quite frankly, it is one of the most important feedbacks on Earth, which is concerning since it is positive in either direction and thus destabilizing. The loop is shown for each potential scenario very clearly by the bottom image. In the scenario on the left, we have cooling, which leads to more ice, which increases albedo, which means less solar radiation is absorbed by the Earth system, which further increases cooling, and so forth. In the scenario on the right, we have warming, which leads to ice melting, which decreases Earth's albedo, which means more solar radiation is absorbed by the Earth system, which further increases warming, and so forth. In both situations, it is a positive feedback because the initial change is reinforced. Let's go over a negative feedback in the Earth system now. There is a negative feedback that involves weathering. Weathering is the process of wearing or being worn by long exposure to the atmosphere, and this is something that happens to exposed rock surfaces. Some of the chemicals in exposed and weathered rock can bind to CO2 and remove it from the atmosphere. Remember that CO2, or carbon dioxide, is a greenhouse gas that causes global warming. So if it is being removed from the atmosphere by rocks being weathered, then things that increase weathering will indirectly decrease temperatures. Something we haven't talked about in this lecture yet is that warming temperatures are associated with more rainfall, which aids in weathering. So looking at the loop on the bottom left, if the temperatures are warmer, then there will be increased weathering because more rock will be exposed to rainfall. The weathering leads to CO2 being removed from the atmosphere and less of a greenhouse effect, which leads to cooler temperatures. In the opposite scenario, if temperatures are cooler, then there will be decreased weathering. Less CO2 will be removed from the atmosphere, allowing it to build up. There will be a stronger greenhouse effect, and temperatures will get warmer. This is a negative feedback because the opposite scenario is occurring in each instance. I gave you another diagram on the right that shows how each negative feedback scenario leads to the other if you want to review it further. There is another negative feedback that is called the Planck feedback or the Stefan-Boltzmann feedback. With this feedback, the higher the temperature of a radiating body, the more energy it radiates. This is a very strong negative feedback, so the total feedback for our Earth is actually negative. But it's so fundamental to Earth's climate that it is often ignored and not considered in feedback discussions. Meaning that when we talk about climate change or global warming, it is already a given and we don't need to mention it. That concludes the material. Let's go through and review the main points. Feedbacks are a cause-effect loop in a system involving a state variable and some couplings. When system output is also the input, we have a feedback. Positive feedbacks act in the same direction as the initial change and are destabilizing. Negative feedbacks act in the opposite direction of an initial change and are stabilizing. The albedo of a planet is a measure of its reflectivity. It is the ratio of reflected to incoming radiative or electromagnetic energy. Albedo affects planetary climate. There are feedback loops that involve life on Earth, Earth's albedo, and more. Thanks for sitting through the lecture. To test your learning, I suggest you review the material and make sure you can complete these exercises.